Alright, what's up guys? This is problem 1.6 out of Griffith's Quantum Mechanics textbook. Before I get into the solution, if you wouldn't mind, please giving this video, went a little crazy there, a thumbs up and subscribing to my YouTube channel. I'd really appreciate it, and I will continue to post more videos like this. Okay, so problem 1.6 is asking why we can't do integration by parts directly on the middle term of equation 1.29. Which I already have written down here, and they're talking obviously about that term. And then it says to pull the time derivative over onto x, and note that dx dt is 0, and include the derivative of our expectation value of x with respect to t is equal to 0. Okay, so let's just kind of work through this a little bit. For the middle term, if we're looking inside the integrand, well, let's just write it out. We have the integral d by dt of x times psi squared. And then we have our dx, of course. So on the inside, if we take these derivatives, we can do, of course, our product rule, and you'll get the derivative of x with respect to t, the partial, magnitude psi squared, plus x d psi squared dt, and then we still have our dx here. And of course, x is not a function of t, so we can safely call this 0. So then we have an integral from, we'll just say a to b, of x, the derivative of psi squared dt, integrating with respect to x. And it's also true, so we've done nothing bad yet, and we can also write this just as we can here. This is completely fine. Now the problem we run into is, notice that we're taking a time derivative and we're integrating over x. So what we cannot do is we can't then say, well, this is just x psi squared evaluated from a to b, because the variable of integration is different than the variable we're differentiating with respect to. So because of this line here, we can't just integrate directly by parts. I hope that makes sense. If it did, please give me a thumbs up and subscribe to my channel. I'd really appreciate it, as I am trying to grow the channel a little bit. And I will be posting more videos every single day.